I've made a number of ACAPs that all uses the video object detection capabilities in the camera. This is the same data that AUA uses. This is the same data as the metadata stream uses. One of them is simple to use, and the other one is way too complex and very costly to integrate with. So my previous ACAPs simplified a little bit, but now I'm showing you a very simple way for you as an integrator to customize to whatever when it comes to using the video object detection data. So this system, this solution is just used based on Node-RED running on the edge and getting that data and filtering it, and where you can focus on the output if you need to do data transformation, and then adding whatever protocol in order to get that data into your system in a user-friendly way, or consumer-friendly way, I would say. Sorry. So you don't need to be a Node-RED expert. You don't need to be a coder, because the flows I'm going to be showing you here is already built into the ACAP, where you can just paste that into your flow and it will give you a dashboard, so you can do the filtering visually when you see how the detection works, and that flow will have an output that you can use to transform data or just attach any kind of protocol to. So without further ado, let's get to it. So to do a more customizable solution or integration with the objects analytics, here is a way to do that. If you are running Node-RED on the camera, as I'm doing here, and we can open up here, and we're seeing a very empty workspace, Node-RED workspace. And there are nodes here that you can get the objects, but you need, in most cases, need to filter things. And one way to do that is if you go up here under import and examples, and let's go the object detections. Can import that, and we see we have a new tab called object detections. We can deploy this. So you don't really need to get into details, but roughly so this is the node that provides the object detections. It pushes that through a filter, and you can get the objects detections after that filter. You can get the objects counter, how many objects are in the scene, and the state. All of these, the remaining flows, are just a user interface to visualize and to set that filter. So you can go up here and go to /UI. Here is the user interface, and we can press start. You see the video quality is not, I've intentionally blurred this with a very low resolution. But we can see here that this is an area of interest, and now we can start seeing all the objects, and you can enable or disable objects and just going specific if you want a car or whatever. And we can save this. So here we see the car. We see the second value is the confidence level, and then how long this object has been in the scene. So here's an obvious false detection, and we can get rid of that in two ways. Either we can say that the object needs to move at least 5 degrees within the 5% within the scene, or we can use the area of interest to filter out. So maybe in this case, I'm only interested in objects on the street, or it could have been that I'm only interested in objects on the front yard of my house. So that depends on the use case, but filtering this now just eliminates not needing to process objects in areas. So here we have a human walking down. we can see the confidence level and we can see number of seconds, and now we're getting a head detection there. If we can look at other views, like in this case, my backyard. So this is just a darkened version of the Node-RED dashboard, but it's the same dashboard. So as you see here that I'm detecting bikes. So these are a couple of bikes I have here. And it constantly updates how many bikes it sees. Now it's 2. And then there is a presence that is, are there bikes in this area? And in this case, I've just limited to this area because I'm not interested in bikes and anywhere else. So saying now we can control the counters is always going to be showing how many objects it does see, but the presence that I can say that it needs to have at least 2 objects is still present. 3 objects still present, but I now go up to 4 objects, and we have a transition period of 5 seconds. So there it goes false. So the presence threshold to flip that state, you can say how many objects. So this would be a very good solution for like a queue management. That, and in that case, you would probably just go heads. How many heads do you see? And if you want to get a notification when there are more than X heads in this area, you can just say, okay, 4 people in the queue. Then the state's going to go high, and we can make some kind of a notification. So you've done now the basic filtering here, but now you want to process that. So if we go back to the flow, so you don't have to move this, but here you could say, okay, now I want to start working on a use case, and this is going to be my output. And the values I will be getting through a link node. You see there are these are the link nodes on the output. So you're getting the detections, you're getting counters, and you're getting state. So in your own flow, you can, let's just do a debug output here, and we will say that these are the detections. And deploy this, and now we're getting detections. Currently there are no objects. We can filter this one to say when there is at least 1 object, and we can make that with a switch node and saying if message payload length, which is, because this is an array, length h is greater to than number 0. Okay, so now we see an array of objects. So we can just pause that, and going in here, we can increase and just looking at, so these are, it detected 3 objects. It detected human, and with a unique ID. It's still active. It's still in the scene. The last time the web before that object disappears, this property is going to say false. So you can trigger on when that ID is no longer going to come back in there. So this is the birth time. You can look at that time in various ways. So this is the time zone that I'm in. You can see how long that object has been in the scene, the birth X coordinates, the birth Y coordinates, the confidence level, timestamp, the bounding box, the center of gravity that I've set. In this case, it's down by the feet. The color. So the color 1 is the upper body, and color 2 is the lower body, and the distance in percent it has moved. And then there's another object. Now this is a head and also a bike. So most likely what we saw coming in here was a human on a bike, that we could detect the bike, the human, and the head. So now you can start doing whatever you want, some specific logic here. Let's say that you're only interested in objects moving left. So we can put a switch node and saying if message payload delta x is, so let's go for going left, meaning if delta x, so this needs to be a number, delta x is less than 0 means it's going left. So on the debug output now, we're only going to be seeing objects with a delta x with a negative value. And you can do more. So in this case, what we're switching here, we can call this any objects, or object detected. And in this case, call this one only left. And do anything kind of an output there. So I think for using object detections, it's more interesting to working on either the state. So you put in a new link node and you will select state. So you can see here that it's going to state, and if I click that one, it will go to this output. So I'm going to have a state, and we can look at, so we can disable this one. So now we're seeing the states here going true or false. So what do you want to do with when the state is going true or false? One thing is you can just add in, if you want to send an MQTT message with the true and false, and you set up a new broker, and I'll just put up my I have an MQTT broker on this IP address, and there's no security, and we can just set the topic's presence. So now every time this toggles, it's going to be pushing that. You can change you can trigger an event in the camera that you could use. Let's see, there we go, trigger. And in this case, it's a Node-RED event that's going to be picked up in the camera. It's going to be state, Boolean true or false. And currently now the camera is generating an event called Node-RED state and going up and down state. Now you can control recordings or even reaching a VMS. You can make an HTTP request to somewhere. Maybe we want to post an image, so we will take a access camera right there, capturing an image on, well, it's not that one, it's this one. It's this camera. So we want to only do that when the state is high. So we'll throw in a switch node and saying when a message payload equals true. So now we're only getting when that when the state goes high. We're taking a picture of whatever resolution. We can reduce this one, pick another resolution there. And the payload is going to come in this picture. Maybe we want a binary or base 64, and basically tie this into an HTTP output to post and to some URL. So here you can do any of your custom integration to whatever system based on the presence. And the same thing goes for adding the counter. Put it in your link node and going the counter. And this will tell you now how many objects, every time the number of objects that you are detecting changes, it will send it and get this update. And now you can do process or doing some custom integration with that. And that is working with the object detections. There is one thing that you may want to add. The cameras may be rotated, or maybe a camera with a specific resolution. It's always recommended to go in here and import from local examples host device information. So you're getting a new tab called device information. You have to go in here and set your credentials to the camera. I have an account called Node-RED with a password. And there's a small little one there. That means that every time Node-RED starts, this one is going to run and making a request if you go to the debug output. So here we're getting camera information, the formats it supports, all the resolution it supports, and also you get the largest resolution, the medium resolution, and the smallest resolution, and aspect ratio, and the camera rotation. You're also getting the camera information, the model, the firmware, and everything, and also the name, which is the host name. So if we go into the global device, going up here and looking at global or in context global, so here this is where this flow is going to store this data. One is going to be camera, one is going to be device, and one is going to be the name. So that is the host name. So sometimes some flows, then when you make an integration, you would like to have some kind of a nice name. So what happens here, that in this node right here, which does all the visualizations and the video output and everything, it actually looks, or this one actually looks in the global context. So here we get camera equals global get camera. So we're getting this data and just double checking that everything there. So this data is going to be injected here, meaning that if the video is rotated in 90, 270, or 180 degrees, the visualization will be according to that. Or if there's a camera with a non-standard resolution, like 69 resolution, so the output will always look good in the dashboard, regardless of what camera. And you can use any other flow can use that. So assuming that I want to, on my output here, on my state, I want to have the serial number behind it. So in that case, I can do here, and I say that message topic equals presence and plus flow get. In this case, there is a name, or no, we're getting the serial number, so it's going to be device, and there is a property here with the serial number and it's serial, and so we're getting the device and then we're taking the serial property. So that's going to be the topic. The payload is going to be the true false, and did something wrong there. It's not glow, it's in this case it's global context, so it's not flow, it's global. That was a global, there we go. Global get device, because this is in a global context, and done. And in this case, we can just remove this because we're injecting the topic. And now, so if we can see here that if we look in the debug output, let's see here. We can disable that, and we can now look and just reset here, and we can wait and seeing if we get a state. If we're having multiple inputs like this, it may be better sometimes for readability and saying that this is the detections. This is the state. And this is the counter. So as you see here, the state coming in, and we made our own. So this is presence, and you get the serial number to whatever system that you're going to be doing that. So what are the main use cases for detections? So one of the common use cases is visualization, bounding boxes, but I don't see that as a real use case. That is more of a demonstration. But for detections, because you will continue detecting things that if I go down in distance here and say, so now it's going to be detecting, of course, this is going to be false detection, but assuming that that was a parked car, you're going to get the state of that regardless if it's moving or not. So the object detections are good for queue management, parking management, where you want to detect stationary objects and counting them or checking their state or things like that. So that's where you're using object detections. So let's look at trackers. And just like the object detections, and you go up here and import the import examples, the access control host and trackers. I've already imported that object tracker, so now we have two tabs and they look very similar, but this one is optimized for trackers. So if we go up here to go into the user interface, we see here now we have two things. We have object detections and object tracker. So I'm selecting tracker and pressing start. So you immediately saw a tracker here. So the difference between the object detection, which just spits out every detection, every bounding box constantly, which is a lot of data. Trackers are more only sending data when the object has moved. And you're getting a little bit more information. So same thing as previously, where we can select that the object needs to pass this area before I even want to be, processing that, filtering and doing whatever. So if we do it this way, and we can also say that the minimum age needs to be whatever to, just to reduce the false detections, and it needs to be moving 10%, and also the area, and we can press save there. And also that I can limit which object type that I want to be tracking. So in this case, I just enable everything. So here we see the trackers coming in, and it doesn't publish that much data compared to the object detections, and it only sends data when the object has moved a certain percentage. So when you use detections compared to trackers, well, what I previously said, that the object detections is mainly for stationary objects when you want to see a parking person standing like a queue, or counting or detecting if objects are within the scene. Trackers are optimized for automation, and in that also means counting. So if we go back here into the flows view, and right there, I can add now an output here and saying I want trackers, and going there, tracker, and I'm putting a debug output way out here because I'm going to be adding stuff to this. And just like we'll just continue and saying this is the trackers. Deploy. Just going to be a previous object there. Go and deploy. Debug output. And connecting this to the tracker. We already did that. Okay. So objects coming in, you're going to have multiple with the same object ID, but I'm going to be doing an object counter flow, and I don't want the to have the data that's coming in from an active object. I want to wait till the last when that object leaves, so I can easily filter that into a switch node and saying if message payload active equals, and in this case it's going to be JSON expression and false, deploy. And now I'm only going to get the last object. So if you look in here, we have now it's a car, so it's false, and we have all the information. What I'm mainly interested in are counting the classes and how many objects are passing. So I'm going to do a counter. So I'm going to be doing a left counter. So only counting objects to the left. So I will call this left counter. Counter. There we go. The first thing I have to ignore is if message payload delta x is greater, delta x is greater than 0, meaning that it's actually moving to the right. So I can just go do a return with nothing here, and it's just going to ignore that. So I'm going to be creating now the counter, and I'm going to be using the flow context to store this counter. And I'm going to get let's just call this left equals. I'm going to ask for the flow get left. And the first time that object is not going to be in there, so I will initially and creating a new object. And the first thing we are going to be doing is car, and setting that to 0. There we go, comma. Let's do human 0, bus 0, truck 0, and bike. And I think we can also do bus. We already did. So those are the things I want to be counting. So now left is that object. I can use the class here to get to these properties. Let's see if we rebuild it there. So then I can say that left and with a brackets, left and message payload class, which is going to be not class. And in this case, I can just do plus plus because that is a value, that's a number. And so if this is a car coming in, it's going to be addressing this object, car, and increasing its value. And now I'm going to be saving it. Flow set left. So that is the storage name, and the data is going to be left, the left object. Left. There we go. And now we can go up here into the context data and we can refresh here. And now we see the left counter and car 1. So this flow is just going to be continuously updating these counters. I may not want to have this published constantly, so we can just, we'll remove that one, move it. I want the counters to be published on MQTT every 1 hour. So I will put in an inject node saying inject once and at interval. Now you're not seeing interval every hour like that. And now we can add a change node saying that message payload is going to be flow left, picking up that data and putting that in payload. And or let's put also a topic here, and the message topic is going to be path, no, counter, so counter data there. And now I can put an MQTT output. So now I can easily, that's done. So now the whole setup here is this part here just keeps counting all the objects into the flow view. So now I see there are 3 cars. Every hour, this is going to take this and send this object to on MQTT for a system to do whatever into database or graphing or something else. The last object type that I'm going to go into is path. And same thing that you go up here and you go import, and I've already done that. So here's my tab path, and it looks very similar to object detections and trackers, but it's optimized for path. So if we go into the user interface, we can start and saying the area here. So you immediately see a car there, and hang on, I'm just going to be saying this is the area that the object must have passed. If I want to ignore my there, save. So when objects move around in this area, you're getting a path. So the green here is where the object was detected, and there was when the object disappeared. And if you leave this up here, you will quickly see what I would call a path heat mapping, seeing how objects have moved through the scene. And that is the typical use case. Path data is first being stored in a database, and the use case is after querying the database. And that may be dwell heat mapping, flow heat mapping, forensic search, counting that you didn't know what you wanted to count, but you can pull up the data and you can count that from the database and to Graph and Grafana or whatever. So this data includes all of this data. So it's just one data structure coming out. And the same thing here, where you can say whatever class you want, the minimum distance, and the area it needs to pass. So if I'm only interested in vehicles coming in, so you saw one object coming in there, that it needs to pass this area, and it's not going to be anything that moves in my front yard or on any other side. That's not going to be counted. So if we go back here and saying that, getting into the flows view and going to the output. So let's add another thing to consume here, and it's going to be path and path right there. And I can do a output like that, and just for readability, copy and paste this and calling this path. So as I said, that the most common use case would be to push this to a database somehow. One way would be to do MQTT and MQTT out and saying this is the path topic, and now it's publishing the data structure coming in. I can put the debug output here so we can see when it comes in. And we see paths coming in here now. And so the data structure looks a little different. You have a unique ID, you have confidence, you have what class it was, the timestamp, and this was when it first was detected, and the age was when it died, the total delta X movement and the total delta Y movement, the distance, and the longest dwell time. So it also keeps track of how long the object was in each sample during its movement in the scene. So we can see here that there were 15 positions that were sampled, and this was the first center of gravity, and the duration, this was just a first object. The second, it spent 1.5 seconds in this area and going up to the last one, and this is where it was died. So it was 0.1 second there. And you get the color of the vehicle in this case, which is gray. And you can push that into the database, or that we can push it directly to a Mongo database, and we can just search for MongoDB. I will take this one. Oh, it was already installed, so I can just do a MongoDB out and creating a new where your Mongo database server is, and whatever database, could be objects, whatever, and that you are going to be inserting that into a collection called path. So you can populate that Mongo database directly from the camera, so you don't need to go through a bridge to do so.